happens every second. It's always moving. Now, if that buffer system does not work, what happens next? Well, the body says, well, I've got to fix this. The respiratory system. So you'll breathe a little bit slower, or you'll breathe a little bit faster because you're controlling CO2. If I stop breathing, or I breathe too slowly, my body retains CO2. When I retain carbon dioxide, I can't talk today. When you retain carbon dioxide, your pH becomes more acidic. When you blow off too much carbon dioxide, your pH becomes higher, so it's going to be more basic. Alkaline or basic, correct. So if your body is too acidic, are you going to breathe faster or slower? Faster. Faster, because your body wants to maintain that balance, that homeostasis. It wants to be in this range. Now, if my pH is too high, the body's going to say, hold on a second, let's slow the breathing down. Let's retain some of that carbon dioxide, let's lower that pH. Think about it. The three byproducts of metabolism are heat, water, and carbon dioxide, right? So whenever you're working out, you're running on that treadmill, your metabolism is speeding up. When your metabolism speeds up, you have more carbon dioxide, so you're breathing faster. You see, the human body does not breathe based on levels of oxygen. You guys in here right now, as long as you have COPD, none of you in here breathe based on your need for oxygen. You breathe based on your levels of carbon dioxide. So when you're working out, you're breathing very quickly. When you're home watching TV on your couch, you're breathing very slowly. Why? Because your metabolism slows down. So your breathing is based on your metabolism because the byproducts are heat, water, and CO2. Very, very simple in that aspect. So in the event that the buffer system doesn't work, which happens instantly, and the respiratory system does not work, which happens minutes, hours, things like that. And the last one is the renal system. This is the one where your kidneys are like the last ditch effort. Your body is trying to maintain that pH. And that's when the kidneys will excrete or absorb ions to try and maintain this pH. If you ever notice people that have diabetes, they always end up losing their kidneys. Why? Because people with diabetes have changes in their pH. And whenever your kidneys die, you have to go on that dialysis machine to keep on pulling all that fluid and cleaning your blood. So pH and acid-base balance is really no mystery. It's just based on the potential of hydrogens. If the pH number is lower, now draw a quick chart, you can take a picture of it, make it simple. So if this is 7, that means it's neutral. Over here is 0, and over here is 14. So if this was a scale here, it's safe to say the human body, 7.35 to 7.45, is always slightly alkaline. When you go down this way, the number goes down, but the hydrogen ions go up. There's lots of hydrogen over here, right? Lots of hydrogen. Think about it, like hydrochloric, hydrofluoric acid. These are all very acidic. As you go this way, the number, yes, it gets bigger, but the hydrogen ion concentration goes down, or it's none at all. It depends. Something like 0, like hydrochloric acid is 0. Oven cleaner and things like that are very, very alkaline, so they're going to be 14. So it's always backwards. If the pH is low, that means the hydrogen is high. If the pH is high, that means it's alkaline. So that means that the hydrogen ion concentration is very low. They're always backwards of each other. So in the event that, well, remember some of you maybe lifeguards, or some of you right now, your pool boy's over at your house. Yeah, he's not checking your pool, but everybody knows what's going on. Whenever he's over there, he's checking that pH, right? Because you want to keep your pool slightly a little bit acid, right?
That's acidic.
A little bit acidic because you want to kill those germs, kill those bad things, those pathogens. But anyhow, this is pH in a nutshell. If it goes down below 7, the 6.9 and beyond range, your body has a lot of problems. You're going to die. What are some conditions that can cause this acidic? You see, changes in your pH can only happen one of two ways: respiratory or metabolic. If I stop breathing right now, my pH is going to go other way, down. The pH goes down because the hydrogen ions go up. So if I stop breathing right now, I'm going to be too acid. If I breathe too quickly, like anxiety attacks, what happens to your hands? Your hands get all tensed up, you get all tingly, feel like you're going to pass out. Your pH has gone too high, you're too alkaline now. So if you're breathing too slowly, that's acid. If you're breathing too quickly, that's alkalosis. Now, the other way I told you about was metabolic. Your pH can go too high, it can go too low based on metabolic problems. Take, for example, metabolic alkalosis. If I drank like 4 or 5 things of Maalox, what's going to happen? Well, Maalox is an antacid. That means it's very, what? Alkaline substance. So if I drink a whole bunch of alkaline substance, what happens to my pH?
Goes up.
It goes up, correct, it goes up. Think about it, if you look at a little roll of Tums, what does it say? Do not eat more than 4 Tums in 24 hours. Like, why is that? Well, if you eat too much of an alkaline substance, your body becomes too alkaline. It's very simple. Let's look at the other side of the spectrum. Metabolic acidosis. Well, that could be something like if I drink a whole bunch of an acidic substance, that could cause a metabolic acidosis. Or what happens if I'm a diabetic? If I'm a diabetic, I go into this condition which is called DKA, which is kind of outside the realm of what we're talking about. But your metabolic problems can cause you to be acidic. So what can cause your body to fail? Basically the same things that regulate in the first place, and that's going to be metabolic disorders or respiratory conditions. So that's kind of broad in general, but that's the overview of pH. It's potential of hydrogens. It's a scale from 0 to 14. The lower the number, the more hydrogen it has. That means it's acidic. The higher the number, the fewer hydrogens it has, and that means it's more alkaline. Correct. Absolute neutral is 7. The human body is always 7.35 to 7.45. So this is acid-base in a nutshell. Does anybody have any questions?
No, thank you.
It's pretty straightforward. Pretty straightforward.